in preparation for graphing exponential functions, we're going to go through and look at what are some of the essential parts of graphing. What steps am I going to need to take? And those steps are 1, find the shape, and then steps 2 and 3 are going to be asymptoting points. So the goal here is not actually to graph, but to prepare ourselves to graph. So when we're looking at the shape, we look at just general exponential function right here. Y equals a times b to the x minus c plus b. Again, that's the general function where a, b, c, and d are numbers. What I want to key in on is the b and the a, because that's what's going to tell us about our shape. So in order to find our shape, the first thing I need to determine is, do I have growth or do I have decay? And we've seen that growth is whenever I have a base, the bottom of the exponent, a b value bigger than 1. And decay, I'm going to label as a b value between 0 and 1, some sort of usual fraction between those two. So that's how I tell growth or decay. So growth, we already know that graph looks like that. Is increasing. Decay, I know I have some sort of graph that is decreasing. But there's more to it than just that. If I take those graphs and I now incorporate this a value right here, I can say this is growth, and specifically growth whenever I have a positive leading coefficient. This is decay, and specifically decay when I have a negative leading coefficient. So if I take those, it's always possible that I can reflect them. If I change my leading coefficient to a negative, we know that a negative leading coefficient reflects it upside down. So that means my graph for growth would go like that. That's a reflected growth. Or I could have a reflected decay that goes like that. I'm just taking my original graph and flipping it upside down, flipping him upside down, reflecting him over the x-axis. So right here are my 4 shapes, the 4 shapes that can occur in any exponential. And I usually summarize them in a little picture that looks like this. Now the green is not supposed to represent a coordinate plane. It's just supposed to be 4 options: a growth, decay, a positive, and a negative. And the positive and negative come from the leading coefficient. And I just remember that when I put them all together, there's growth, the 2 options, normal and reflected. And there's decay, my 2 options, normal and reflected. They make this fun little picture that shows me the 4 possible shapes of an exponential. It's a super important little picture that quickly lets us identify whether I have growth, decay, positive, negative, and what the shape corresponds to. So if I look at a couple of examples, notice I've gone ahead and put my picture down here, growth, decay, positive, negative. The first example, I check out the base. What's being raised to the exponent? There's a base of 3. That's growth. And more than just growth, it is positive growth, because that leading coefficient, that 2, is positive. So positive growth is going to put me right there. So that's the shape of my graph. So if I look at the shape of this exponential, it's going to go like that. Really important to know what the shape should look like. Second one, my base is going to be the number raised to the exponent. I have a base between 0 and 1. 2/5 is between 0 and 1, so that's decay. And I have a leading coefficient that's negative. So if I come over here, negative decay, or reflected decay, looks like that. So the shape of this graph is going to look like that, right there. There's more to it, but that's just my basic shape. For this example here, I have 1/8, which again is between 0 and 1, that's decay. And I have a positive leading coefficient. So I know that according to my picture, it's going to be regular decay. So his shape is going to look a little bit like that. And lastly, this is probably the hardest one to see. Oh, let me go back for that. Oops, forward one. Oh, he's got to go away. And he is gone. There we go. Ah, everything went. Let me rewrite it quick. Sorry. That's decay. That's positive. And that picture. Here we go. Last one here. Now that I'm back on track. That 5 is my base. That negative right there is a -1. So 5 is the B, -1 is the A. So I see a base that's bigger than 1, so that's growth. And I see a negative leading coefficient, so that means reflected. Reflected growth puts me down there. So his shape's going to be something like that. So being able to dissect these two and get the shape is the first important step in order to graph. Second important feature of every graph is an asymptote. You remember the parent graph of e to the x, he went up like this, and he had a horizontal asymptote at y equals 0. So when I look at all of my other exponentials, every single one of them is going to have a horizontal asymptote at y equals some sort of number. And we just have to look at how is that asymptote then shifted. And since it's y equals, it's going to be affected by the y values. So I look, and every single time it's going to be whatever the shift is on the outside. So I'm looking at the outside, and the outside. That's going to show me how the asymptote's been moved. The first one, it's been moved down 4. New asymptote's y equals -4. Here it's y equals 3. This guy's a little trickier. He has not been moved up or down at all. There's the +0, so he stays at y equals 0. And the last guy is moved down 4, so he's going to be y equals -4. So we have the shape, we have the asymptote. That's going to give us a good picture of the graph. That's enough to get us what we call sketching. And lastly, I want to find some points. And here I can pick any x values. So any x values. Because the domain of an exponential is anything, I can pick any x's. I'm just going to pick what I call smart x values. X values that are going to be easy to plug in. So what I think about as smart is I want to plug in x values that make the exponent 0. That's my goal in order to get what I try to say smart value. And when we do points, I'm going to do 2 of them so I can make sure I have my shape correct. So if I go ahead on the first one and say, okay, I need 2 points, I look up here and say, what x value can I plug in there to make that whole term equal 0? Well, if I plug a 2 in, I get a 0 for my exponent. And then you can plug it in the calculator. It doesn't really matter to me. You should get a -2 out of it. That's just an exercise in calculator then. You're putting 2 times 3 to 0 minus 4, and you should see that 3 to the 0 is 1, 2 minus 4 is -2. Don't care how you get it, as long as we get that accurate answer. And then in general, what I say is we go 1 step away from that point, so either to 3 or to 1 for the x value. So maybe I'll go to 3. I'll plug that in. 2 times 3 to the first minus 4 is 6 minus 4, which is 2. Again, you can just plug that in your calculator. And at this point, it's very repetitious. I'm going to find 2 ordered pairs for all of them. I put a -2 right here to make him 0, so that's my first choice of x. Then take 1 step away. Maybe I'll go to -1. If you plug them into the calculator, you're going to find that the -2 ends up giving you a 1 value there. And the -1, I'm going to have to plug it in, -2 times 2/5 to the first plus 3 gives me somewhere around 2.2 or 11/5. Doesn't matter how you write it. The key is the first point. I want to make the exponent 0. The second point, I just take 1 step away. So for the sake of time, I'm not going to go through all of these, but here I would plug in 0, and I'd get out a 2, and then maybe I'd plug in 1 and get out whatever that value is. For this one, I'm going to plug in a +1. Again, I'm trying to make the exponent 0. And in that case, when I put in the +1, I might end up getting -5. And then I take another step either way. Maybe I'll plug in a 0 and see what I get out. So the key is just picking smart x values. In other words, the first number I choose makes the exponent equal 0. So just to finish up really quick, we're going to go through tomorrow and put this all together in order to graph some exponential functions. But to get some credit for watching the video, go ahead and just take care of what's on the screen. And again, we'll put it all together tomorrow.